Hello, this is my presentation for Chemistry 2 at Doane University. We are doing another interactive concept presentation. So today we're going to be doing a classic. We are going to be doing some baking soda and vinegar reactions. So I have the stuff already prepared. So rolled up in this paper towel is about a spoonful of baking soda. And then over here, about maybe a fifth of a bottle filled up with vinegar. Distilled white vinegar is what I'm using today. So what we're going to do, we're going to put this guy into the bottle and see if we can get a reaction. So it is technically a bottle rocket. I'm going to be doing it on its side because I don't have a way to prop it up. But I'm just going to very quickly put this in, screw this on lightly, just kind of set it on it, put it on its side, and we'll see if we can get a reaction out of it. So I'm going to do this pretty quickly because I don't want it to explode in my hands. So, like I said, make sure that's all twisted up. Okay, let me show you what's happening. So, as you can see, there is a reaction going on. It is not exploding though. So, there's a couple things that could have happened here. First of all, potentially too little vinegar or too much baking soda. So, depending on those two things, because you do need to have a certain reaction to get that pressure. The reason why people do vinegar bottle rockets is because when you have this kind of reaction in an enclosed bottle with a narrow opening, you can often get that buildup of pressure that we're looking for. And like I said, unfortunately, we're not getting it. It definitely has reacted a little. It's clearing up now. But let me talk a little bit about what we had expected to happen. So, like I said, we combined baking soda and vinegar. The reaction type is an acid-base reaction. So of course the vinegar is the acid, the base is the baking soda. So this is a two-part reaction. So the first part of it is the acid base, and that's called a double displacement reaction in the case of this. The second reaction part is the decomposition reaction. So what we have happening, those two parts. So in the first one, it's going to react to form carbonic acid and sodium acetate. Those are the two things that are happening in the acid-base reaction. Then we're going to see that decompose. So from there, those two things are going to yield carbon dioxide, CO2, H2O, and also sodium and acetate. So those things are going to cause the reaction that we see where it has that buildup of pressure. So yeah, like I said, unfortunately, we're not seeing that reaction, but we've learned this week that it does take a certain amount of ionization and a certain amount of acidity to keep the acidity up high and to cause a proper reaction, and we did not get that here. I think likely it was too little vinegar. That's my best guess. I didn't put in as much as they did in our sample video, but I did shake it up to get the reaction started. Another thing that could potentially influence it is temperature. Our vinegar was in the fridge, so it was a little cold, so that can slow down the reaction. Not only that, I am currently in a very cold state outside, so the coldness out here might be minimizing as well. But yeah, sorry you didn't get to see a cool bottle rocket, but we did try it out today. But yeah, we still saw an example of an acid-base reaction. There was some fizzing, there was bubbling, carbon dioxide rose because it is lighter, so that rose, oxygen water down, We can even see that in, sodas with the bubbles and the carbonation there. But an acid-base reaction can be a very helpful thing. It doesn't always end up with a bottle rocket explosion. It can also lead to things like fire extinguishers is an acid-base reaction. So it's a very, very helpful chemical reaction to know about. And I hope you enjoyed my bottle not exploding. But hopefully you learned something about acid-base reactions today.